Welcome back, everybody. And today we are graduating from this little stepper motor here that many of us have used from our Arduino starter kits to something a little beefier, the NEMA 17. And we're going to control speed and direction using a regular old Arduino Uno or a clone like this one, as well as our A4988 motor driver. If you want to get further into robotics or 3D printing or building your own CNC machine, this is probably the first stepper motor that you're going to try out. And as we learned with this stepper motor, you can't just control these directly with the Arduino or power them because they draw too much current. So you can see he is still attached to his motor driver. So what are good motor driver options for our NEMA 17? Well, there are several of them. One of the first ones you'll encounter is this A4988. And the main way you pick which motor driver you want to use is basically the current rating of your stepper motor. And my stepper motor needs 1.5 amps. And just a couple specs on it to make sure that it is the right one for your stepper motor. It can handle an output voltage of 8 volts to 35 volts, but the logic input voltage can be between 3 volts and 5.5. So this is great for a variety of Arduino boards, both that run on 5 volts like the Uno and the ones that run on 3.3 volts. It's most comfortable at that 1 amp continuous current. But for short bursts, you can hit that ceiling of 2 amps if you need to. And it's capable of not only doing full steps, but also half steps, quarter steps, eighth steps, and 16th steps to give you those buttery turns. Now, your NEMA 17 stepper motor might look a little bit different than mine, but one thing it's going to have in common is the size of this faceplate. It's got 17 in the name. So if you take 17 divided by 10, you get 1.7 inches. And that's how these stepper motors get their name. And just to double check, we can see that we're at about 1.7 inches. So if you happen to have the NEMA 23, you're going to expect a larger faceplate. Where these stepper motors differ is basically the length of the housing here. So you can see mine is pretty short. There are even shorter ones, but yours might be a long tube. And generally speaking, the longer the housing, the more torque and typically the more current it's going to need to run. But before we get this little guy hooked up, let's talk about some heat control. This motor driver chip can get pretty hot, especially if you start running it above an amp. So according to the datasheet, if you're going to do that, they recommend using this little heatsink. Now these come with our motor drivers and you attach them just by removing this double-sided tape and popping it right on top of the chip. Just be careful that it's not touching any of the pins on this side or on the other side, and it is especially not touching this little potentiometer here. But a word of warning about these little sticky tapes. As the chip warms up, the adhesive on this heatsink starts to become pretty soft. And what happens is that this will start to shift around ever so slightly, and it can accidentally touch pins, touch the potentiometer, or these other pins, making contacts that aren't supposed to be happening. So I highly recommend pulling this off and using a thermoelectronics adhesive instead. That's going to give you a much better and far more reliable bond than this little sticky tape situation. With that aside, let's start wiring it up. Starting with the left side, we have our EN pin, and that's your enable pin. So normally it is pulled low. You don't have to connect anything to it. But if you send a high signal to it, then it'll disable the board. It may be a good idea to perhaps connect a button to this enable pin. That way, when you push it, it's a way to just immediately stop your stepper motor driver, especially if your project is going haywire. And then we have the MS1 through MS3. Those are for our microstep selection. So whether you want to do full steps, quarter steps, by using different combinations of highs and lows on these pins, that's how you activate the different stepping modes. Next up, we have the reset and sleep pins. And this just helps you control your power states along with the EN pin. So for reset, You can reset the entire board so that way the stepper motor starts back up at a home position. And sleep is convenient for a project where maybe you're not always using your stepper motor. So you could put the board to sleep and conserve energy for your project. And then the next two pins are the only two pins we're going to be connecting to the Arduino. And that is the step pin and the direction pin. So anytime you bring that step pin high, your stepper motor is going to take a step. And then anytime you bring the direction high, that controls the clockwise direction. And then if you pull it low, it should turn counterclockwise. And now the pins on the right. So we have that VMOT or VMOT and the ground. This is where you're going to plug in external power to power your stepper motor. I'm going to be using a 12 volt, 3 amp power supply. Then the next pins in blue, those are our stepper motor control pins. And so we are going to be hooking up our stepper motor to each of those pins in the proper order. And I'll show you how to do that. And then finally, we have another group of power pins, which is the VDD and the ground. Now, this is how the board itself gets power. So VMOT and ground are for the stepper motor, and VDD and ground are for the Arduino. Since this is the only component going into the breadboard, I'm just going to smack them right in the middle. And you want to pay special attention to the location of the potentiometer so that way we can match it up to the pin diagram. The first thing I'm going to do is connect the reset and the sleep pins together. Because if you don't, those are going to stay low, and low means that this thing is going to stay asleep. So we need to wake it up for our examples. So in order to do that, we have our step pin, our direction pin, and then it's these two pins that I'm going to connect. And I'm going to use the tiniest little jumper wire that I can find and just try and get them all happy talking to each other. This will pull them high, so that way your board doesn't fall asleep on you. The top ones here were for powering the stepper motor. And so then VDD and ground must be these two pins. So let's go ahead and connect them to the Arduino. The second to last pin is our VDD. And I'm going to put that into this 5 volt pin of the Arduino. You can see my labeling is getting a bit worn off there. And then this last pin on this side is going to be our ground. And this is also going to go into the Arduino in the ground pin. So we got those two guys together. So I'm going to stop the connections at this point because I'm going to sneak a little something in. Oh yeah, I am springing this on you because we have to actually set a current limit for our driver. It's not just going to deliver magically 1.5 amps. This is a super important step, and a lot of people skip it and then wonder why their stepper motor got fried. Before we proceed with the wiring, let's just get that out of the way. And it's really easy to do. All you need is a multimeter. And even if you've never used one, I'm going to walk you through and you'll get yours set in no time. All we're going to have to do is turn that little potentiometer right there until we get the current we want. And there's two ways to do this, and I'm going to show you the easiest way, because the Rachel way is always the path of least resistance. For this process, you don't have to have your stepper motor connected. In fact, it's best if you disconnect it. And I'm just going to disconnect these two temporarily to show you where you're going to put your probes. All I'm going to do is clamp an alligator clip to the metal shaft of your screwdriver. And that's what we're going to use to turn the potentiometer. And so we're going to get a reading from the potentiometer basically through your screwdriver without ever having to touch anything. And then putting these guys back, we still need to access this ground. So an easy way to do that is the ground can come from anywhere. So there's a whole other ground pin right here. And I'm going to plug that in like that, leaving me a free end. And for that, I'm going to use a black alligator clip and clamp that to one end like that. And this other one will clamp to the black probe. So your ground connection is complete and it's totally hands-free. And the last connection I'm making is to the red probe. The only thing you have to do now is turn this little screw. So I'm going to fire this up to read volts. Why volts? Aren't we trying to limit this to 1.5 amps? The reason we're using volts is because we're going to be measuring the reference voltage. Here's a much better wiring diagram showing you how I connected the multimeter. Now, of course, the alligator clips are missing from this, but you saw how I did it. So the reference voltage equals the current that we're trying to limit this to multiplied by 8 and then multiplied by the current sense resistor. Now, what the heck is a current sense resistor? Looking at the driver module on the left side, you're going to find two resistors right next to the chip, and you can see that they're stamped. This one in particular says R100. Whatever your stamp says, it is really easy to look up online and it will tell you the corresponding resistance. For the R100 label, that comes to 0.1 ohms. Using that equation, I'm aiming for 1.2 volts for my reference voltage. The last thing we have to do is plug in the Arduino, just so it gets power as well as the motor driver module. I'm going to put the screwdriver right in the center. Now you want to make sure it's well seated. I'm at 1.17 because I've already been fiddling with this thing. And slowly turn it. You're going to notice that there's a lag between when you turn it and when the readings catch up. So turn just a smidge and pause until you find that reference voltage that you want. Now, my goal is to always set it just either at it or slightly below, which was 1.2. 1.18 works for me. Setting the current limit is done. All right, let's continue. I'm going to remove this extra ground here. Right next to the sleep and reset pins were our direction, which is this bottom one here, and the step, which is right next to it. So I'm going to start with the direction, and we'll use green for that. I'm going to put that into pin number 2. And then for the step pin, which is right next to it, we'll put it into pin number 3. And that's it for our Arduino connections. All we have left is power for the stepper motor and then the stepper motor itself. So let's start with the power for the stepper motor. On the top right of the driver module, you'll see that connecting to a breadboard power rail along with an electrolytic capacitor. A decoupling capacitor is really important to include in the power supply portion of your circuit, because what it does is balance out any voltage spikes that might come through that would otherwise be hitting your stepper motor and potentially damage it. I'd start with at least 100 microfarads. Here's your VMOT and your ground. So the objective when you wire this up for real without the breadboard is to put the capacitor as close to these two pins as possible. But for breadboarding purposes, I have a minus here, so they do have polarity. I'm just going to put him right there. I'm going to take this first pin right here, which is that VMOT, or I'm calling it VMOT. You guys can call it whatever you want. And make sure that that goes into the positive rail along with the positive lead of our capacitor there. And then right next to the VMOT is our ground. And I'm going to squeeze him in like that. And our ground is going right into this blue power rail there, which corresponds to the negative of our capacitor. And finally, we need a way to get power in. So what I like to do is pick up these little female DC jack adapters and conveniently stick some jumper wires in there. And that makes it really easy to power and prototype your projects. So making sure I'm putting them in the right orientation. Sometimes I'm quick and I forget, and then we get some nice little burn marks happening. This makes it really easy to hook up to a power source. The last thing is the stepper motor, and these are going to go into the remaining pins right here. The orientation of these wires matter, or else your stepper motor is not going to work correctly. And even if you have the exact same colors as I do and you try and hook it up the same way, the wire order might actually be different for your stepper motor. So now how am I going to know how to wire this thing? You guessed it. I got another trick. I need more sleeves. These tricks are just pouring right out. But mostly it comes from me frying a bunch of stuff, so you don't have to. There are 2 coils inside the stepper motor. So all we have to do is match up which 2 wires goes with each coil. And the best way to do that is manually. So all I'm going to do with nothing connected is spin this shaft and get a feel for how much it takes to spin it. It's pretty easy to spin this thing. What we're looking for is what wire pair makes it difficult to spin, because that means those 2 go together to the same coil. So I'm going to start with red over here using this jumper wire, and let's try the one right next to it, and that is blue. So I'm connecting red and blue together. What happens? I don't really feel a change. All right. So what about, let's do red and black, because that's almost like positive, negative. It's almost like they need to belong together. But alas, it was not meant to be. I don't really feel any resistance. All right, so that only leaves green. So it's like red and green. They're like Christmas colors. Oh, that I have to really put some energy in there, some oomph to turn this thing. So now we know Christmas colors, red and green, go together for my stepper motor. This may be different for yours. And therefore, black and blue must go together. That's like a bruise color. So we got like Christmas and bruises. That's an awful combo. And yet, indeed, it is much more difficult to turn. You see that I have our Christmas colors, our red and green, grouped together for the top pins, and then our bruise colors, the black and the blue, grouped together. Now, wire orientation doesn't matter. You can connect the red and the green on the bottom or the bruise colors up top, so long as those pairs stick together. You can purchase the matching connector, but for my purposes, I'm just going to stick jumper wires in here, matching up the colors. And in my case, you see they don't go in order. So I'm going to have to group these 2 together and group these 2 together, whereas the wiring diagram on the manufacturer site actually had them grouped like that. And the first motor output pin is the one right after this ground, and then black and blue. So long as your pairs stick together, you'll be fine. And I'm going to momentarily just get these guys out of the way. And then put them back. Every pin on this side is taken up. And on here, we're only using these 2 pins for now. You can always use the step select, which we'll get to a little later. Oh, and already the stepper motor is bowing out. It's like, I'm done with this tutorial. I know what happens. You're going to turn this on and I'm going to fry anyways. When making connections with your stepper motor, always try to remember to have it not powered as well as your Arduino. Because if your motor driver is powered and you start pulling these wires in and out, that could actually damage your driver. All right, this one has no confidence in my skills. The wiring is hooked up. If you guys have any questions about what you saw, I have a fully detailed tutorial. Link for that is below. It'll have all the wiring diagrams that you saw along with step-by-step instructions. But you know what time it is. To the code! All these Arduino sketches that we're going to be looking at today was written in real time with my community members, done via live video chat. So that way I can look at your circuit and you can share your screen and I can see your code and we can troubleshoot together. Link for the community is below. The first thing you'll notice is that this sketch is super tiny. That's it. That's all it takes to spin your stepper motor. And you'll notice that there's no library. So the first thing I like to do, and this is optional, but I recommend it, is to define your pins. Give them a unique name. So I'm using the constant integer variable type. And integer means a whole number, which suits pins, and constant because the pins aren't going to just jump and change numbers. So I have the direction pin set to pin number 2 and the stepper pin or the step pin set to number 3. That way, if my project gets bigger, which it always does, and I need to move these to another pin, I have only one place where I need to change the numbers, and then it updates it for the rest of the sketch. So you're not sitting there finding and replacing everything. And then moving on to the setup, I declared our pin modes. So how do we want these pins to behave? Either as an input, where we're going to be gathering information, or as an output. Well, both of them are going to be output, because for the direction, we are going to be outputting from the Arduino to the motor driver which way we want this to turn, clockwise or counterclockwise. And same thing for the step pin. The Arduino is going to tell it it's time to take a step. And just to give me time to get to the table, I added a 2-second delay. And for this first example, let's just pick one direction. So I'm going to digital write that direction pin high. That means that technically it should turn it clockwise. Writing it low should turn it counterclockwise. So once we have our direction set, let's start making it take some steps. To do that, I'm going to digital write the step pin high. That's going to allow it to take a step. And how fast do I want it to take that step? We're all used to seeing the delays, but you're going to get a lot more smooth movement if you use delay microseconds. So this stepper motor is going to take a step at 5,000 microseconds. And then we want it to pause before taking the next step. And so now I'm going to digital write that same step pin low, or shutting it off. Also for 5,000 microseconds. And you can use different values in each of these, kind of get like a little dance going. But if you're running a robot or any type of machinery, probably want to keep them the same number. And indeed, it is turning clockwise. And I put this straw with a toothpick. It's a little shaky, a little loose, but it shows you how smoothly it pretty much turns. And here we're taking full steps. And while this is running, it's a good idea to start touching it. Is it getting hot? That way, you know if you need to make adjustments to your current limit. But unlike the stepper motor, you want to be real careful touching here, because even if it doesn't run very long, this can get hot enough to burn you. By using delay microseconds instead of delays, you can get that smooth motion where you barely see the steps, except for my loosey-goosey straw setup. So if you want to see distinct steps, let's just drop it down to delay. And instead, maybe I'll use 250 microseconds here and do the same here. And we'll see some more distinct stepping. So here the steps are a lot more noticeable, and this might work for your project. Now let's turn it the other way. So all I'm going to do is swap this to low, and perhaps let's speed things up again. So I'm switching this back to microseconds, or delay microseconds. And I think I had it at 5,000. And indeed, now it is turning counterclockwise. Let's see how fast we can get this thing to turn. And 1,000. That turns nice and smooth, even though it's taking full steps. So let's play around with some of the other step modes by connecting to our MS1, 2, and 3 pins. To activate these other stepping modes, we just have to know what orientation the highs and lows have to go across these 3 pins. And I, of course, have a chart for that too. So looking over here, if we don't have anything connected to MS1 through MS3, we're in default full step mode. So let's try maybe quarter step. And so low, high, low. With both the motor and the Arduino disconnected, let's hook these up. Now remembering the first pin was our EN pin, the enable pin. So the one right next to that, well, that's gotta be MS1. And I'm gonna put that into 8. And then MS2 is right next to it. This is getting kind of squishy. And that's gonna go into 9. And finally, MS3. And that is going to go into 10. Here's an example sketch to use the microstepping feature. So you'll notice all I've done is create pin variables for those microstepping pins, MS1 through MS3, and associated them with the correct pins. They also need pin modes of their own because the Arduino is going to be outputting information to these pins to tell it which microstepping variety we want. I decided to flip the direction back to clockwise. And here I'm setting the step that I want, which is the quarter step. And so if we recall from the chart, MS1 has to be low, MS2 high, and then MS3 low. Now, of course, you can change microstepping within the loop, but here we're just going to set it one time. And to make it easier for us to see, I went and dropped back down to the delay using 250 milliseconds. Guys, look at how slow it's turning. You can barely see it, but it's only taking a quarter of a full step. So you can get really smooth and precise. Let's try and move it a little faster. I went back to delay microseconds and I'm using 2000 microseconds. Hopefully you get an idea for how the microstepping works. And I am just gonna, don't forget to disconnect. And I'm going to remove this to put us back in full step mode. So far we've set direction and speed and it just keeps looping. But what if you want your stepper motor to make a full rotation at one speed going one way? And then another full rotation going the opposite way, maybe it's going to do it faster. So let's see what something like that looks like. So nothing up here changes. We still have our pins. You see that the microstep select pins are gone. And another variable that I set up, also a constant integer, is the steps per revolution. How many steps does it take for the NEMA 17 stepper motor to make one full revolution? And the answer is 200. Different stepper motors have different revolution numbers, but for this one, it's 200. Nothing changes here in the setup. Both pins are set as outputs, and I'm going to give myself a little 2-second delay to get over there. Then in the loop, first, I wanted to rotate clockwise. So if we remember, we have to digital write that direction pin high. And let's start with a slow motor speed. So here, I wanted to go one full revolution. So remember how we were digital writing the step high and then low? Well, I don't want to do that 200 times, okay? So instead, I'm going to use a for loop, which is a great way to take a step that's really repetitive and tell it, hey, do this X many times. Once you're done, get out of it and go on to the next thing. So for this for loop, you need an initial state. Where are you starting at? So here I created a variable called step. And we're starting at step number 0 because this thing hasn't moved at all when you first fire up the Arduino. And here is the condition. So long as this condition is true, it's going to execute this code in this code block here. So long as the step is less than the steps per revolution, which we defined as 200 up here, keep taking one step. And plus plus is just fancy for saying step equals step plus 1. So long as we haven't reached our full revolution of 200 steps, it's just going to keep executing this 200 times. We are going to tell the step pin to go high for 500 microseconds and then low for 500 microseconds. So once it reaches its 200, it's going to add 201. So when it comes back here and says, is the step, which is 201, less than 200? Well, that's not true. So it's going to jump out of this for loop and go to this delay. So it's going to make a full clockwise rotation at a speed of 5,000 microseconds per step. And then it's going to stop for a second, catch its breath. It was running, but it's about to sprint now real fast. And now we're going to rotate counterclockwise. So now it's time to set that direction pin to low. And we're going to spin that stepper motor faster. Again, using the for loop because I wanted to take a full rotation back again, we're going to start at step 0. And so long as the step is less than 200 steps, keep adding steps. So we're going to digital write the step pin high, and this time we're going to go faster at 1,000 microseconds. So that's a very quick little step. And then low also for 1,000 microseconds. Now, of course, when it tries to take that 201st step, this condition will no longer be valid. So it's going to jump out of this whole thing and pause for a second before then repeating the whole thing all over again. So let's see what this looks like. That's our slow and then counterclockwise fast. And you see it is making a full rotation, paying attention to where our little toothpick finishes. And that backwards flip is nice and smooth. Well, maybe now you don't want the backspin to go a full rotation. Maybe you want to do a full rotation clockwise and only half a rotation counterclockwise. Let's see what that looks like. We got to experiment a little bit. So the first spin clockwise, I'm going to leave alone. It's going to make its full spin. But then this fast one, I only want it to do half a circle. So right here, I'm just going to alter this for loop. We're still starting at step number 0, but I don't want it to go a full 200. You can replace this and just write the number 100, but I always like to keep my variables. So if we only want it to go halfway, why don't we just divide by 2? Our full rotation. Nice. Oh. And yeah, it is only going halfway on that backflip. By just controlling the direction pin and the step pin, you can create a whole orchestrated robotic movement. If you guys have any questions about the code you just saw or any of the wiring that we went through along with setting the current limit for your motor driver module, don't hesitate to post in the comments below, or better yet, join the community, and link for that is below, because every week we get together for live workshops. We have office hours where you can share where you're getting stuck on your project so we can work through it together, along with our Arduino project challenges, where we keep pushing boundaries and get out of the comfort zone a little bit. Hope to see you guys there, but in the meantime, I got robots to build, and I hope you do too. So I had a blast, and I'll catch you guys next time. Bye!